Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. And if you need global distributions, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. This week's episode is also sponsored by Data Coral, an AWS native, serverless data infrastructure that installs in your VPC. Data Coral helps data engineers build and manage the flow of data pipelines without having to manage any infrastructure, meaning you can spend your time invested in data transformations and business needs rather than pipeline maintenance. Raghu Murthy, founder and CEO of Data Coral, built data infrastructures at Yahoo and Facebook, scaling from terabytes to petabytes of analytic data. He started Data Coral with the goal to make SQL the universal data programming language. Visit dataengineeringpodcast.com/datacoral today to find out more. And having all of your logs and event data in one place makes your life easier when something breaks, unless that something is your Elasticsearch cluster because it's storing too much data. Chaos Search frees you from having to worry about data retention, unexpected failures, and expanding operating costs. They give you a fully managed service to search and analyze all of your logs in S3 entirely under your control, all for half the cost of running your own Elasticsearch cluster or using a hosted platform. Try it out for yourself at dataengineeringpodcast.com/chaossearch, and don't forget to thank them for supporting the show. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, Alluxio, and Data Council. Upcoming events include the Data Orchestration Summit and Data Council in New York City. Go to dataengineeringpodcast.com/conferences to learn more about these and other events, and take advantage of our partner discounts to save money when you register today. Your host is Tobias Macy, and today I'm interviewing Matthew Baird about AtScale, a platform for data virtualization and a universal semantic layer. So, Matt, can you start by introducing yourself?
Hi, thanks, Tobias. I'm Matthew Baird. I'm one of the co-founders of AtScale, and I have a long history in enterprise software and data and analytics.
And do you remember how you first got involved in the area of data management?
It goes back a long way. By training, I'm a math and statistics guy. Grew up and went to school in Waterloo, Ontario, Canada, and I got into enterprise. I don't think anybody grows up and is like, I want to be an astronaut. No, I want to be a data and analytics guy. But I ended up in enterprise, and data's really important there. So my first programming job, was around when the internet was being really used to build web applications. And I saw the value of building a web application server that was more data centric and about pulling data out of databases and letting people manipulate the data, do analytics. And we delivered that as a product very early, I think in 95, actually. And it was excellent because I got to work with all the guys that were sort of pioneers at that level, exchanging emails with guys like Mark Andreessen and the team at Netscape as they were building out, that level of infrastructure. That led to, sort of what I would call the original data companies, which were companies like PeopleSoft and Siebel and Oracle. And I had a career that spanned multiple visits to those companies, usually through acquisitions of startups that I either started or worked at from early on. I think driving intellect and using data to figure out human behavior is something that really drives me personally. I'm very interested in that. It is kind of like the basis of when you look at machine learning and statistics and that stuff, it all leads to this: how will people behave when given this data? And I worked at companies in the startup space that did things like sales incentive compensation management, which is really about using data to drive behavior of salespeople, and they're really great for a microcosm of behavior, because they are, as we used to say, they're kind of coin operated. It's very pure. And then I did a bunch of marketing analytics companies that were more thought of as the big data companies like Conductor, which got sold to WeWork, and Yield Software, which got sold to HP. I took a little left turn into consumer with Ticketfly and Inflection. And then at the end of that, I said, you know what? I've been building this platform at all these companies and sort of doing a good job, but not productizing it. I should go start a company. And that's when AtScale took off.
And so, as you said, you've been having to replicate the same functionality a lot of different places. I'm wondering if you can start by describing a bit about the types of functionality that AtScale enables and a bit about the platform itself and how it fits into the current ecosystem of data tools.
Absolutely. So I come at this from more of an application builder. I was a VPE CTO type of guy working at startups mostly. And a lot of those challenges are, let's collect a bunch of data, or let people input data, or whatever data comes into the system, and then I'm going to do some sort of post-processing transformation on that data, and I'm going to sell you back either intellect or the ability for you to derive intellect from that data. That's very common. If you look at Conductor is a great example. We crawled the web, we collected a bunch of data, we let you enter some extra data from your enterprise, and then we turned around and we gave you a user experience that was all about, let me look at how people are finding my marketing content, and then slice and dice it by machine type, by browser type, by geo, by, these are all business intelligence analytics questions. And when we built those tools, typically what we do back in the day, whether you use Hadoop or even pre-Hadoop, you drop the data somewhere, you post-process it, put it into a relational database so you could actually query it at a speed that was acceptable for building these user experiences on top of, and then you'd manage that whole pipeline. And it was a big pain in the ass, because you never could just drop the data in the source system that could also serve it. Then along comes Hadoop, and Hadoop could kind of do this, or there was some hint that maybe Hadoop could do this. So we started to look at that technology, and what we decided that we would build would be initially a big data analytics or a BI solution on top of Hadoop. It was that easy. We wanted to replicate the functionality of best of breed tools like Microsoft SQL Server Analysis Services, or any of the other tools that you see the enterprise using, but we would be able to eliminate or greatly push down the need to do all the, and some of this is in retrospect, to be honest, Tobias, eliminate the painful IT data engineering that had to happen to make that analytics possible. So we delivered that initially, and it's evolved over time because we started in Hadoop, and Hadoop is the challenge of getting performance on Hadoop is really one of data engineering, right? Like, it's somewhat query tuning and traditional DBA type stuff for driving performance of a database, but there's a much larger portion of it that's around, how is the data laid out on the disk? What are your partitions? Are you doing sorting? Are you doing all the stuff that you do in Hadoop to drive performance? And that led us to automating those, first identifying scenarios where we needed to do it, and then automating the actual data engineering that happens to enable this sort of more real, no, I don't want to say real time because it's not real time, but this more interactive business intelligence type query flow. So what happened over time was we expanded from single data warehouse and Hadoop to cloud data warehouses, because that was a trend that was happening. And then beyond cloud data warehouses, it would be multiple data warehouses, both on-prem and in the cloud. Nobody ever moves all their data all at once. They're constantly looking at, maintaining legacy and pushing on the new technologies that are available. So we created a technology that we could leverage the IP that we built around what we now call autonomous data engineering, and move that into the space of supporting multiple databases, multiple locations for the data in a way that was transparent to the user. So from a data and engineering data management perspective, AtScale occupies what I think is like a new and exciting space around leveraging virtualization technology to enable an end result, which is analytics. And I think we're the only company that's really doing what I would call autonomous data engineering for analytics. There are some traditional virtualization vendors that focus on federated queries and caching. Those are absolutely necessary, and they are strategies that need to be implemented, but they're one of maybe 2 or 3 dozen different things that we do to enable our core value proposition, which we've really simplified this down. We're interested in performance, security, and agility. And then in the cloud, cost savings is a very real thing, because I think the second month after you get to the cloud, your CFO usually gives you a call and tells you you're spending too much money. So, sorry, I'm talking a lot, but how it manifests itself is we built a virtual data warehouse, which means we look like we're a database, but we're not a database, and it can connect to any data anywhere and present it as one universal semantic layer, and we'll talk about what that means. And then you can query it from all your tools. So at the end of the day, you have this one data service, and you can fulfill all your data needs from that. And we worry about the intricacies of scaling that up from a concurrency and performance perspective. Now, I think universal semantic layer gets a lot of airtime, and just to be clear on what that means exactly, there are strings and numbers in databases. We all get that. And then in the real world, there are business and real world constructs like a customer or a hierarchy or a dimension of time. Those things have some analogies in the low level type system in the database, but what we want to do is up level that to present it in a way that it makes more sense to people that consume data that aren't necessarily experts. So for instance, I want to drill from country down to state, down to city, down to specific zip code. That's a hierarchy. That's a thing that exists in the real world that you can express in a database, but it's not super easy to write that query. There's a lot of group bys, joins, all the other stuff that happens. It gets even harder if you're doing it across multiple databases. So we present that semantic layer to the user so that they can do the analysis they want without having to worry about the complexities. The end of the day, abstraction is a wonderful tool for solving problems, even for business people who don't necessarily understand the concepts around abstraction and why it's valuable. You encapsulate complexity, push it down.
And so it sounds like there are a few different concerns that you're covering in your overall capabilities that are partially covered by some of the different open source platforms out there, such as some of the SQL query engines, such along the lines of Presto or metadata management at some level for being able to identify what data do I have, sort of the data catalog aspect of things. And all of those are useful tools in and of themselves, but as we said, there's a lot of extra engineering time that needs to be dedicated to just making sure that those are running, that they're able to perform at the scale that you need, particularly as your volumes of data grow or as the data sets change, and making sure that the on-disk aspects of the data are optimized for those different query engines. So I'm curious if you can talk a bit more about some of the types of tools that somebody might be using in an existing data stack that they've built themselves that they might be able to replace by moving to AtScale.
Absolutely, you're right. There's a ton of open source out there, and I've been involved in open source for over 2 decades as a member of the Apache group, as a PMC for db.apache.org, and contributed tons of code and tons of my personal time to open source, and I love it. We've contributed open source at AtScale as well. We made a decision that we weren't going to open source necessarily the full platform that we have, and that's more of a business decision. That's a different business model. But the technologies that I think people are using today, let's think about that. Clearly we are not in the landing data space. You set up those data pipelines independently, and we come into play after the data lives in a enterprise data warehouse, multiple enterprise data warehouses, or a data lake as the newer construct for that. And then you have open source technologies that deal with getting that data to the end user who's using a Tableau, using a Power BI, maybe using an Excel, perhaps consuming it via JDBC or ODBC and building a platform around it. That there's a ton of technologies around that. Sometimes, in fact, there's none, and it's just very raw. Let's put Impala here, or let's put Presto, as you said. Those technologies are wonderful, and we leverage those and we support those. We make them better. It's like a chocolate and peanut butter thing, I think people would say. You have the ability to accelerate and scale Hadoop in a way that is not involve having to hire and retain very expensive and hard to find Hadoop folks. And it's easy to set up Presto. I get that. It's very easy to set up Cloudera, Impala, and have that work on Hadoop. It's not as easy to get it to work in a way that scales. Like, for instance, at one of our customers who's a very large credit card company, to scale to multiple petabytes, hundreds of thousands of people accessing it. that requires some really smart folks, and they have really smart folks over at that company. They have a lot of things to do. So, if you can automate some of that, that's the part where I think we've done a really unique job of delivering a solution that hits the market where there isn't any open source necessarily to do this, around automating the data engineering tasks necessary to deliver a production view of data in a way that scales. But very specifically, let's think about this. There is, what is that one from Apache, has something called Kylin, right? Yeah, Apache Kylin, Apache Druid. Those are two technologies that I think are Apache Kylin's probably more on the OLAP side, Druid more of an aggregation engine. Those are interesting technologies. They're super rough around the edges, to be clear. It's not a technical assertion. That's more my opinion. They do not wrap an end-to-end solution, so you're constantly piecing together a bunch of things into the platform, and then you still have that issue of you've got to do the data engineering yourself, and there's no real, I don't think there's anything in the open source that does that today.
And can you talk a bit about the actual technical implementation of AtScale and how it's architected and some of the ways that it has evolved since you first began working on it, particularly given the shift in where people are spending a lot of their time and focus on, one, how they're treating their data and storing it, and two, the types of platforms that they want to be able to integrate with?
Absolutely. So we started the company 6 years ago, as of September, and when we sat down, we talked about like what would be the stack that we would use. Clearly, on the front end, you're like JavaScript, HTML, CSS. That's not, you don't even need a decision there. That's just the way it works. Whether you use Backbone or React, wait a couple weeks and the JavaScript stack will change. So we just picked the best thing that we could, and we architected the front end really well to adapt to that. In the middle tier, we decided that what we would build would be an API server, and we did not want to hire a whole bunch of engineers to work on the middle tier. We wanted to have a high leverage language that we could use, and I had been working with Go for probably 6 months beforehand, and I was very encouraged by how you could use Go. You could go away, you could come back, and you could look at the code, and literally there was no friction for just stepping into that code and maintaining it. That's been, I'd say, an incredibly successful solution. And I know that there's never any language that universally everybody loves, but in terms of having a very small number of people maintaining a large code base and being able to hire onto that code base and maintain it, almost in a part-time way, it's been super successful. The performance has been fantastic. And honestly, in the enterprise, some people said, "Oh, if it's not on the JVM, nobody's ever going to let you run it." Not true. It's been fine. It's been adopted there. That's for the middle tier and the API services. And then on the back end, I worked with one of my co-founders, Sarah Gerwick, who is a huge fan and a leader in the functional programming space. And while I think maybe if we lifted all the restrictions, she might have gone with something much more exotic. But the choice was, it's got to be on the JVM. It's got to be something that works well with what the big data tools are familiar with. So at that point in time, it was, the big thing was Spark was starting to take off. Hadoop was definitely a thing. And we really wanted it to be functional so that we could deal with more naturally with data in a scalable way. So we chose Scala, which runs on the JVM, of course. And it's been a good experience. The language is highly leveraged. You don't have to have a huge team of experts. You got to have some smart folks that understand the concepts. And I think honestly, it's been good for attracting the sorts of engineers that we like, that want to do interesting, tough problems. I know that there's play for Scala and everything else, but I think if you're using Scala to build web applications, you're missing the point. It's much more powerful as this back end language for doing heavy algorithmic work, which is what we're doing. So from an architecture, from a language perspective, that's what we're doing. From an architecture perspective, the front end now is all in React. We got rid of a lot of the backbone stuff. We've been, you always, as I said, are progressing that JavaScript stack. What we built on the front end is a Google Docs-like multi-user concurrent application for designing data models and data services. And that we used WebSockets, and we used a sub protocol of HTTP called the Web Application Messaging Protocol. to do this pub sub type thing. Worked out really nicely. I'm happy. The architecture scaled. It's low bandwidth. Because fundamentally what we're doing is we're concurrently working on a thing that isn't a check-in, check-out, or a merge. It's not, you don't want to have merges and forks and everything right in the face of the users. They're not used to that. So while we do support things like versioning the artifacts that we're building in Git, you aren't ever presented with a Git merge that you have to go through. It uses MVCC, multi-version concurrency, to order the messages and then bring them together in that architecture. So that's on the front end. The middle tier, pretty straightforward, RESTful interfaces, JWT for security, cores so that we can talk to, so that the front end can talk to both the engine, which is running in Scala, and the middle tier, which is running in Go. And then on the back end, what we built, fundamentally we built an optimizer. It's like a database optimizer, and it understands more the nature of the data that's distributed across multiple infrastructures, and every piece of technology in that chain, whether it's network, and in fact it transcends technology, and it has concepts around cost, because when you are trying to optimize a query across multiple databases, it's no longer just that you have the optimization objective be pure speed. You want to create a scenario where you can optimize for other outcomes and then blend them together so that whoever's running this data infrastructure can get what they need out of it. And whether that's pure speed, you can do that at the expense of cost, right? I have elastic compute resources, I can scale things up, but you have to have that nature of, is this data co-located? Is it going over a low latency network? Is it going to cost me an arm and a leg to serve this out of BigQuery or one of the per resource basis? So a little bit more about it. The design center builds the virtual schema. The engine runs them. It's sort of it is a very much a software project derived metaphor. You build, you deploy, and you test, and you run it. That's for these data services that we're dynamically generating. We used to be on Hadoop, as I said. It used to run on a Hadoop node. Now we have no tie to Hadoop at all. We run on any image, any VM, any cloud. We're not tied to Hadoop. We can talk to every cloud database out there. Yeah, and is there anything else on the architecture side that might be interesting to your listeners?
No, I think that's a good overview. And I'm also interested in you were mentioning that AtScale is built to be able to interface with multiple different data warehouses. And you said that it also integrates with Hadoop. And I'm curious what you have seen, particularly in recent years, as far as what the breakdown is of people leaning towards data warehouses or data lakes, and particularly with the advent of cloud data warehouses that are starting to blur those lines.
That's a really good insight. I think that we're starting to see, I don't think the data lake definition is nearly as crisp and concise as say what a EDW definition is, and I do think that the cloud data warehouses have blurred that even more. Typically we thought of a data lake as, I guess traditionally it would be, this is where the data lands and it's unfiltered and it's raw and it's ready for doing whatever you're going to do to consume on it. But typically that involved doing some ETL, pushing it into a different database or a different technology. And then EDWs were the filtered, curated, ready to go. This is blessed. Let's go have it. The nature of data has changed in the enterprise. People are, I'd say, the forward-thinking companies are more interested in getting that data in a perhaps less filtered. They'd love to have it more filtered and more concise, but they think that the speed at which they can get the data to the users so that and the agility that those users can consume the data is more important than necessarily providing this beautifully manicured data experience. And you see that in the spaces of data, machine learning, and things like that. But those cloud data warehouses have the capability and have a cost model that's not prohibitive for storing tons and tons of data. So they can serve both purposes. And then that means that they can serve all the different constituents and all the different consumption patterns. As I said, whether it's business analytics, operational databases, KPIs, ad hoc, machine learning, or whatever other things are coming along that path. I think I've said a bit. Is there anything in there that's interesting that you'd like me to drill in on?
No, I think that's good. And for somebody who's using AtScale, particularly if they already have an existing set of infrastructure, or even for people who are coming from Greenfield, I'm wondering if you can talk through some of the workflow of getting AtScale set up and integrated with their systems. And then for somebody who's using AtScale for doing analytics, what that looks like.
So we have a combination. We serve the global 2000s. People with lots of data, probably lots of databases. Some of them are newer companies, like Wayfair. I'd say is one of the newer companies. They've come up in the last 5 years, and they have a very forward-thinking attitude towards data. And I think if you can go and read about what the guys at Wayfair are saying about data publicly, they're doing a lot of things really, really smart, really pragmatic. And while it is new school and cutting edge, it does represent where I think that the market's going, and that is, let's give them one place to consume data, let's give them tools to find the data, and let's give them an infrastructure that makes it so that when they start to use that data, whether at small scale or large scale, we can grow with the consumption of that data and make it work for, they have thousands of people consuming data. And their attitude is everybody should have access to all data, except in the case where it needs to be governed or there's a compliance issue, in which case they apply that policy at that single data service entry point. So for them, to answer your question, I just my chief product officer always says when somebody asks me what time it is, I tell them how to build a watch. I feel like for engineering, the implicit question is always how does this work, and what are all the edge cases, and contextualize it. So for those sorts of forward-thinking organizations where data is considered to be like air and it should be available to everybody, it's a single RPM install. You model some data, so you register your data warehouses. You build a virtual data warehouse, you deploy it, and you just start querying, and that's it. It's very, very easy. Now you have to have access to the data warehouse, which some companies, whether if you're a Bank of America or JPMC, God bless you for having controls on that, because I'd be worried if you didn't. So you have to get access to those data warehouses, and in some cases that has to be secure. And Kerberos, is challenging. It's probably always going to be challenging. It's a tough system to work with, but it's what a lot of enterprises use. So you got to go through that part of the scenario. And then getting better at using AtScale is about being able to iterate and put something in the hand. If you're an IT group or you're a data sort of producer type person, you build something, you give it to people to consume, you gather the feedback, you iterate, and we're really good at that, because once you're in the role of serving people that consume data, what you find out is they're always changing their mind on what they want, and when they want it is now. So being able to model something and hit a button and deploy it, and the service instantly flips over and represents those changes, is hugely powerful, because in the past those consumers of data have been like, okay, I got to fill out a Jira ticket, I wait anywhere from a week to a month to hear back on the status of the ticket, then a software project happens, and then I get the new data element, because they had to build a data pipeline, they had to do ETL, blah blah blah, all the way down the line. They don't want that. And I would argue that data engineering folks don't want to be in that space either. There's a lot of interesting data engineering tasks out there, and not a lot of them use the three-letter word ETL. There's a lot more interesting things to do. So we handle that for them from an analytics perspective, so that they can go and that workflow for implementing AtScale is very simple, and the iteration process and the maintenance ongoing is very easy.
And what are some of the main challenges that people are facing in their sort of uh, traditional, quote unquote, data engineering workflows, particularly if they've got a strong focus on ETL that they can just hand off to AtScale once they implement it? And what are some of the ways that you have seen people use their time that gets freed up by virtue of not having to do those types of tasks anymore?
So think of this like, you remember when Salesforce came out, when I forget when, but their motto was no software. Um, there was software. And when we say there's no ETL, there's still ETL. It's a matter of what part is automated versus what part falls outside of the purview of the analytics use case. You still have to be able to write data pipelines and whatever tool you end up using, whether it's open source or commercial, for landing the data. You still have to do the work of potentially doing some data wrangling or some data profiling if you need to improve or augment that data in a significant way. But once you've got it to the point at which you think that there's this is a good, valuable data set, and potentially it lives with a bunch of other data sets in a warehouse, where we can help is the users can self-serve on, and we have customers actually doing this. I didn't actually expect that there would be a user that or a customer that would roll out our design tools to users so that they could design and build their own data warehouses and have them be productionized all without involving IT at all. But if you think of it, it's kind of almost like what MuleSoft does for APIs, but we do it for data. So we make it easy to do it. We give them some automation capabilities, and then we roll it out. I think I went off, and I think I've lost track of what the core of the question was, Tobias. I'm really sorry.
I was just trying to get an idea of some of the ways that people are taking advantage of the extra time that they get that is freed up by virtue of not having to do as much ETL once they start using AtScale.
All right. Well, that depends, I think, on the organization. I think that you would be best served to have your data engineering team working on building out what some people call the real-time enterprise or streaming, and figuring out how to improve the latency and the quality of the data as it pertains to collection, in all the ingest stuff, and then potentially, I think that has much higher yield because garbage in, garbage out, faster data, faster is better. The streaming use cases, nobody's really figured that out yet, at a sort of an enterprise scale. So that's a great place to spend your data engineering time. There are, I read this statistic somewhere and I wish I could remember where so I could attribute it, but I went back and checked, and it's true. There are 7,500 job openings for data engineers in San Francisco. There are 7,400 people with the title data engineer in LinkedIn for the US. So we have more demand for data engineering skills in San Francisco than we have supply in the US. I'm sure they're going to find something to use those data engineers to do if they don't have to go and get this data element and make it available in Tableau for the marketing group. That should be automated. I think we can all agree things that should be automated or can be automated probably should be automated. Um, that's an ethos that we really believe in, and it's not about taking away jobs at data engineering. In fact, it's about making data engineers much more happy in the work that they do. Look at what they're doing. If you join data engineering teams at Facebook or Amazon or Google or any of the big cloud vendors, those are really interesting challenges. Making a data element available for an end user is super high value from a business perspective, but not a fun engineering challenge.
And in terms of challenges that you have been faced with in the process of building and growing the AtScale platform, I'm curious what have been some of the most interesting or unexpected ones that you've had to overcome, and some of the most useful lessons that you've learned in the process?
I think hiring and finding the right people to work on the types of problems that we work on that are extremely algorithmic in nature. We Every single thing needs to be scalable to multi petabytes. On the engine side of things, which is the Scala based software that we develop, it's all about getting the right person in there and then getting them up to speed on essentially how databases are built. Even though we're not a database, we're kind of doing database like development, but even harder because we have to support all the databases out there. I think that the heuristics, there's unsolvable problems that we have to approximate with kind of like heuristics and identification of scenarios. So let's take an example of a kind of problem that we solve that's turns out to be really hard. Doing pre-aggregating and doing a pre-process step on multiple petabytes of data takes a really long time. And if you want to compute every possible combination that somebody could and every join path, it'll blow out your data massively, right? So think of it as this is the old school of how OLAP worked. We'd calculate all the combinatorics and we'd roll it out. My co-founder, who was at Yahoo, had a 2-week build time. Some of our customers have multi-days, and in today's enterprise and today's consumption of data patterns, like days, you're already dead. You can't be looking at 2 days ago when you're running flash sales, or you're spending $1 million a day on some marketing program. You need to have up to date data. So that wasn't an option. But also, not doing anything up front means that as soon as people start to query the data, you have no information and you have no acceleration. So the queries take minutes, hours potentially. And there's a fine line where you're doing something that's smart, that's predictive, but you're doing it before you get all those traditional signals that you'd get from having the wealth of queries coming in. Like queries are the natural expression of interest from the end user community, right? Like they'll tell you what they want if you go and gather requirements and you talk to them face to face, but what they really want is represented by how they query the data. So we have to make this decision, and there's a major challenge in building up things that I think have never been built before, in figuring out when do you have enough data and how do you deal with a small amount of data but still give a good user experience to people querying. That's been probably the second biggest challenge after hiring. I mean, of course, you need those people that are smart enough to do that type of engineering. Yeah, I think those two are things that I think about from a technical perspective. From a business perspective, I think virtualization has been, in the past, traditional virtualization has failed. It's kind of it's become a word that's associated with a specific implementation, a traditional implementation, and we've moved past that. And you're a specialist in data engineering. You know that, like, what, 15 years ago there wasn't really I don't, when did data engineering become a term that we used and it became a career? How long is that? A decade?
I think it's within the last 5 or 6 years that it's really become a discipline in and of itself. I mean, it's a set of responsibilities that have been around since we started dealing with computers, but in terms of an actual distinct role, it's basically it postdates the introduction of data science as the sort of new and interesting career path, because then companies were spending all this money on data scientists and realizing that the majority of their time was actually spent doing all of this collection and preparation and cleaning work that wasn't actually providing the end value that they were expecting. And so that's when they started breaking it out into its own discipline.
I see you've done this for real. Yes, data engineering enables anything that has to do with data in your company. And those folks, like, it didn't exist. When you put a name and you create a career around something, it has a way of sort of forcing the codification, the definition of what all those things are. Like you said, we were doing some of those things. In some cases, it was tribal knowledge. It was split across multiple different types of people in the organization. But once we created a career path around data engineering, things started to crisp up. And that's what enabled us to look at it and say, these are the things that are going to require humans. These are the things that probably a machine's going to end up doing. That's inevitable. And then, going through that process of figuring out how to identify those scenarios and build them out, that was, so I'd probably put that in third place for the challenge of building the company. And that represents a business challenge as well. I think, as I said, traditional virtualization is based on predates data engineering, and even some companies that came along that maybe didn't start in the same way that we did and look at the problem the same way, went back to virtualization as being a federated query and caching issue and not an automation of data engineering tasks problem. So educating the market and getting them to understand that, I know you've heard this term, but it doesn't mean what you think it means, and it doesn't carry the baggage that you think it means, has been a big challenge. Not a big challenge. I mean, people see it, we show them, they get it. But I think from the perspective of sometimes language gets overloaded, that's challenging. So we've experimented with creating new terminologies for this, but at the end of the day, sometimes they actually like the comfort of hearing language that they've heard before.
What are some of the most interesting or unexpected ways that you've seen people using AtScale, and some of the misconceptions that they might have going into it that they are pleasantly surprised by when they discover some of the true capabilities of the platform that you've built?
So As I said, we focus on performance, and performance is a term that means a lot of things. Like, can a single query come back in a reasonable time frame? Can you scale queries to whatever the size of the consumption pattern is? So handling concurrency, handling scale, handling per query performance is what performance is about. Security, agility, and cost savings. And I think the two places where security is sort of table stakes, the areas where people are surprised are, how do we drive performance in a way that's completely hands off? How easy is it to build and deploy these data services? I think I drive the salespeople in my company crazy, because I'll go completely off road, and we can build a model and deploy a model in a meeting and not do like a pre-canned demo. And then the cost savings. The cost savings are something that we actually probably didn't really think about as much, because you typically don't lead with that sort of like costs. It's a race to the bottom in traditional enterprise, but in cloud it's been a big deal, and we see some very large reductions in cost. And the surprising thing there in the cloud is, I don't think the cloud vendors mind that we say we're going to save you money on a BigQuery, we're going to save you money on Amazon, on a Redshift, we're going to save you money on a Snowflake. They're looking at the longer game of, if I can improve the unit economics of analysis and make this platform more cost effective from an ROI perspective, you don't constrain what you're doing and say, great, I came in under budget. You maximize the use of that technology, and you create more use cases, you create more opportunities for people to come and use the data, because you know that you have a scalable cost model around it. So guys like Google and guys like Amazon have been, very, they've been open about it. And we take a company like Home Depot's a wonderful customer of ours, and we did very specific things in our implementation for BigQuery that solve you can write a query that costs a lot of money, and you can express that query a different way, and it costs significantly less. Say a join, increases the complexity of the query and the slot utilization in BigQuery versus enlisting it, or doing another strategy. We can do all that stuff in an automated fashion with query rewrite, and we get them to the point where initially they thought they'd have maybe a couple hundred people on the all you can eat 2000 slot program, but really now they're able to get that into the multiple, like 5,000-6,000 people consuming and getting the same exact answers at the same price, but they get that in an automated fashion. From a use case scenario, there's three that come to mind that were surprising to me, and maybe this is more because I'm a technologist and not necessarily a business person. But the AbbVie gave the design center, they thought that the design center was so usable and such a great experience that they gave it to their analysts and said, here's the data, here's the tool, design your own use cases, roll them out, query them. You are entirely in charge of a production level self-service initiative. That was, I'm very proud of the work that we did to make a high user experience product, but I didn't think that it would be one where they'd give it to people that weren't necessarily data modelers. The Home Depot, we talked about them already, but they have a massive spreadsheet that's super important for the business, goes all the way to the top of the CEO. I know everybody disparages Excel. I don't. I think it's fantastic. It's a tool. It's probably responsible for creating more programmers than any language in the world. Specifically, everybody's a little programmery when they get into Excel. And that tool is so important that all the stores have it. We were creating a use case that is sort of suppliers and internal folks. Fantastic use case, but the scope of exposure of that data to people across the extended Home Depot family was amazing. And I really like the Visa use case. It's not surprising. It's actually more satisfying me, because the reason that I started the company was to build an addressable, programmable platform that wasn't necessarily just going to be people on Tableau consuming it. It was about people building businesses and building applications on top of it, and that's what they did. And they built I think there's multiple hundreds of thousands of their customers access trillions of rows of data on a giant, probably the best and biggest use of Hadoop in the world that I know of. It's a completely valid use of Hadoop. I know it's popular to hate on Hadoop, but it's wonderful for them. They have to keep their data behind the firewall, and they have so much of it that really nothing else will work. So that was really interesting. My co-founder, as I said, is more of a pure BI guy. So, having people connect Excel and Tableau and Power BI and query all day is fascinating. But I wanted to enable the developers that have had to just gyrate wildly to get software built that accesses large amounts of data. Now they can do it, I'd say, relatively straightforward with the combination of virtualization and the automated data engineering that we do.
And by virtue of the fact that they're accessing the underlying data through this abstraction layer that handles some of the optimization aspects, it also helps in terms of future proofing and reducing some of the risk of experimenting with new tools and platforms, because you don't have to re-implement any of the client side code. You can just add in a new data store, test out to see if it does what you want and if it has the sort of cost and performance patterns that you're looking for. And then if it doesn't work, you can just take it out again without having to do a whole bunch of retooling and re-engineering of the rest of your stack.
This guy programs. You know what it's like. You it's the first thing you do if you don't know what the implementation is going to be on the back end. You create an abstraction in Java. It's an interface. Golang has more of a duck based contract system. You build that abstraction, you test it out to make sure it works, and then you're given the freedom to change the implementation without having all the client code have to change. And in this case, client code is, quite frankly, it's humans. Humans are the hardest code to change. They get stuck in their ways. They figure out a way to do something, and they want to do it that way forever. So giving that freedom to the IT and the data engineering team, I think you nailed it. That is life changing. You want to move a single table. You want to move all the tables. You want to go from on-prem to off-prem. We've effectively created an abstraction that gives you a software switch for controlling where the data is and how it's accessed, which gives freedom.
And when is the AtScale platform the wrong choice?
Well, we're not an OLTP platform. We don't handle what I would call, the sort of like every bit of the SQL spec. We are a multi-dimensional analytics platform. So for analytics use cases, it's good. If you want to talk about creating a data service that does sort of both sides, right now we're not that product. More focused in on should you be a customer or not. We deal with, you may have a large amount of data, like you may have big data in a single store. You may have big data in aggregate, and what we find that's much more reasonable is that every company's got big data. It's just in 50 to 100 to 1,000 databases. But if you have a single data warehouse and you have small data, that's probably just throw Tableau at it, or write a web app on top of it, and that's pretty straightforward. You don't need to buy AtScale at that point.
And what do you have planned for future iterations of the AtScale platform and business, either in terms of feature improvements or new product areas?
We're going to keep it simple and focus on performance, security, agility, and cost. And within that space, build a platform that solves for what I refer to as a governed self-service environment. And that means that users need to be able to discover the data. So that's cataloging, metadata management. They need to be able to apply policy in a centralized place so they can decentralize access. And that concept is really powerful when you think about it. And that presupposes that you have sort of a natural path to data that flows through one place where policy can be enforced. And let's see, we are focused now on Global 2000. And we've implemented a lot of things. And this really, you asked a little while ago about open source and replacing open source. One thing where open source, and I love it, but they don't know all the situations that around security that happen in an enterprise. So we've built out a lot of features and functionality to have the best security story of any company out there. And we own big data for the Global 2000. We got to go into the mid-market. We got to focus on mid-market and building products and services that are going to help those companies, because they have big data problems and they have data everywhere problems, just like the big guys do.
Are there any other aspects of the AtScale platform and the work that you're doing there, or the ideas around data virtualization or data engineering automation that we didn't discuss yet that you'd like to cover before we close out the show?
Geez, I think the industry's changing the whole divergence and convergence model when you're solving problems, as I apply that to industries, we are still diverging and the data engineering is growing. It's still being defined. We haven't reached the apex and started to bring that together to make a very concise, these are the technologies, these are the activities, these are the kinds of people that are involved in it. So it's exciting, but it's a big challenge. We're going to have to keep up to date with what the best practices are and translate those into what our product does. Should we be driving tools like Beam or any of those data movement tools? Probably, absolutely. Is streaming going to become a bigger issue? I 100% believe streaming is going to be the challenge for enabling the kind of consumption of data that enterprises want over the next decade. And frankly, the whole tool chain end to end is not ready for it. Even if you look at things like the traditional BI tools, they don't have any way to really work with streaming data. There are point solutions here and there, and some people have gone out and started startups that do it. But for the majority of consumption, that pipeline of ingest through to business analyst, it doesn't exist. So we're gonna have to see those areas change, and we're gonna have to keep up to date with that. I think that so that streaming, the I'd be a bad CTO if I didn't say the ML phrase, but I do think this is actually a space where machine learning and advanced statistics are going to be a major improvement. We like to think that virtualization gives us, and it's not just virtualization across multiple data warehouses, by the way. It's you virtualize a column itself, so it's not necessarily a nominal value; it's a computed value. You have databases that now support pushing machine learning down to the data, and there's ways to do it, but we have to expose that to the end users in a way where they don't have to be mathematicians, but they can get the benefit of having that sort of experience with data where it's more helpful. And I hope it's not going to turn out like, and I'm going to date myself now, like the little Clippy, remember Clippy?
Oh, I remember Clippy. I think everybody who has ever
All right.
experienced it remembers it.
Yeah, yeah. They were way, you think about it, Microsoft was way ahead of the game on building a digital assistant. The problem was that everybody hated him. He's a nice guy. He tried. But I think that those sorts of things are becoming more pervasive in a way that it has to reach people that are doing analytics at companies, because otherwise they're going to be limited in what the amount of analysis that they can do is. It's creeping in with things like NLP, but there's other places where it would be super easy just to do a linear regression and show you when you're looking at a bucket of data that there's an outlier in there. I don't think anybody's really doing stuff that easy right now, but we'll get there. I learned this. I had a Pixel for ever since, or not a Pixel. I had an Android ever since cell phones came out, and I transferred over to Apple. And while the Apple device is beautiful and I love it, I never realized how much the machine learning from Google in that device was helping me with my day to day. And I'm a technologist, and I was obviously aware of it because I was using it every day, but it didn't strike me as being this game changer because it's being evolved into the workflows. We're becoming more and more used to it. The predictive stuff, not just on the text and the speech recognition, but in the applications, plugging it into my car and it's anticipating where I'm going to go. Those sorts of things, it's a very natural flow. That has to happen. And we have to be there as a company, as an AtScale, to enable that flow of information and creating the intellect from the data.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I'm super biased, Tobias, but I do believe that the virtualization model can work, and it will be the way that people build these single data services, and it will be the way that people get broad adoption of a secure, governed, self-service analytics solution for all use cases. And that gap. I think we're in the lead. I think we have a new approach. I don't think we're not there yet, but we're the furthest along, and I think we have the best vision for doing it, because, and then that has to be automated, because the challenge is really that, and the gap is that this hiring won't scale. Data engineers are it's going to be like the hottest, continue to be the hottest and probably highest paid software career for, I just don't see an end to that.
All right. Well, thank you very much for taking the time today to join me and discuss your work on the AtScale platform. It's definitely an interesting piece of technology and one that solves a necessary evil in the data management space. So thank you for all of your work on that front, and I hope you enjoy the rest of your day.
Thank you, Tobias. I enjoyed this.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.
La 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 la.